Okay, so let's start the new scheduling algorithm, that is round robin scheduling algorithm. In this session, I'm going to solve few previous year questions of GATE exam on round robin. So let's quickly solve the problems. After solving this problem, you will be confident enough to handle any type of numerical on round robin. So the very first question is from GATE 2020. What is given here? Let's look at carefully. So there are 4 processes given. The burst time is also given. Now what they are asking is, we need to apply 2 algorithms. So shortest job first also and round robin. 2 algorithm we need to apply. Then time quanta for round robin is given as 4 millisecond. And we need to find out the absolute value difference between the average turnaround time of SGF and R. So I'm drawing the Gantt chart for both quickly and then we can finish it. So let's say this is the Gantt chart for, let's say, SJF, and another Gantt chart I am drawing for round robin. Okay, the total CPU burst is 15 plus 4 19 plus 2 21. So both will have the length is equal to 21 only. So let's say I consider this is the length equal to 21. Here also let's say I consider the same. Okay, so this is I am assuming as SJF and this is for round robin. So now first complete the SJF. This is moment 0 and 0. Every process arrive at same time. I guess it is given. Assume to have arrived at time, or you can say same time. Okay. So arrival time for every process is 0. We are considering, right? Now what is given here? P1, if we schedule when all the processes are already arrived in the ready queue, then we can schedule P3 first here. So you schedule P3, and if you are applying SJF, P3 will consume 2 unit of time and it will terminate. So let's say this is 2 here and P3 has been terminated. After that P4 will be scheduled. P4 will consume next 4 cycles, so it will be terminated by 6. So this thing and this thing has been finished. Now P2 will be scheduled. P2 will consume 7 cycles, so somewhere around 13 it will finish. So let's say this is 13. And then P1 will be scheduled and P1 will finish its lifetime till 20. So consider like this. Now let's look at the situation in round robin. In round robin at 0 moment, let's say P1 is scheduled for 4 unit of time. So let's say this is 4. Then P2 will be scheduled for 4 unit of time. So it is 8. Then P3 will be scheduled, but P3 totally required 2 units. So P3 will finish its execution by 10. Then P4 will be scheduled. It will execute till 14. Right? And then again P1 will be scheduled. So P1 will consume next 4 cycle, let's say 18, somewhere here. So this is also over. Now P2 will be scheduled and P2 will consume 3 cycles, so it will go till 21, let's say. So this is P2. Okay. Now we need to find out the difference between turnaround time. So let's calculate the turnaround time. So if we calculate the turnaround time for one process in case of SJF. Okay, so when turnaround time for process 1 we are calculating, process 1 finishes at 21 and arrived at 0. So it is 21. Then turnaround time for process 2. Process 2 finished by 13, arrived at 0. Turnaround time for process 3. Process 3 finished at 2, arrived at 0. And turnaround time for process 4. 4 finished by 6, arrived at 0. So it is 6. So if we calculate the average here, average turnaround time, it is 21 plus 13, 34 plus 2, 36, 36 plus 6, 52 divided by 4. Okay, that means it will give you, I guess, 13. Okay, and then you calculate for round robin RR. So turnaround time for process 1. For process 1, turnaround time is process 1 finishes at 18, arrived at 0, so it is 18. Turnaround time for process 2. 2 finishes by 21, arrived at 0. Turnaround time for process 3. Process 3 terminates by 10, arrived at 0. And turnaround time for process 4. 4 finishes by 14, arrived at 0. So average turnaround time in this case for RR is equal to, you add all this. So when you add all this, it will give you 18 plus 20, 38 plus 1, 39, 39 plus 10, 49, 49 plus 10, 59, 59 plus 4, 63 divided by 4. So you will get okay, so 15.75. Right, we can again check it whether it is right or not. Okay, so I guess here we have made a mistake. It should be 21 plus 13. It will give you 34 plus 2, 36. 36 plus 6 is not the 52, it is 42, right? So this should be 42, right? And when you divide 42 by 4, it will give you 10.5, right? Okay. So if we find out the absolute difference, so absolute difference means the difference of average turnaround time of SJF minus average turnaround time of RR means round robin. Absolute value, that means we are doing 10.5 minus 15.75. Okay. So if you subtract like this, it will become 5.25, right? So if you calculate, it will give you 5.25, right? So in that way, you can calculate this very first problem. I hope you must be clear. This was asked in numerical type in GATE 2020. So please do remember the answer will be 5.25 of this question. Let's move on to the next question, right? So in the next question, the question was asked in GATE 2012. So let's draw the Gantt chart for this and solve it quickly. Right, so what is given? Okay, so there are three processes: arrival time given and required unit in terms of CPU cycle is also given, right? So at time t0 only P1 will be scheduled. Here we are applying two algorithms, first come first serve and round robin. So let's draw two Gantt chart. First one for first come first serve, second one for, let's say, round robin. Okay, so here I am writing FCFS and here I am writing RR, round robin. Okay, now in round robin the time quanta is given as 2. Okay, so first come first serve, first P1 arrives, so P1 will consume 5 cycles because it is requesting 5. Then till 5 all, like P2 has been arrived and P3 is also arrived, so P2 will be scheduled because first come first serve. P2 will consume 7 cycles, so till 12 P2 will execute, and after 12 P3 will be scheduled and P3 consume 4 cycles, so till 16 it will be executing. Now what happens in round robin? At 0 P1 is scheduled and there is a time quanta of 2, so at 2 P1 will be interrupted. Now let's check. Yes, P2 has arrived. So when the P2 is arrived in this, you can give the chance to P2. So P2 will be scheduled here for 2 unit of CPU cycle. So till 4. Till 4 P3 will be arrived. So if P3 will be arrived, then you can schedule P3. You can maintain in round robin scheduling, you can maintain a queue. So for better understanding, you can maintain a queue so that in the order of queue you can pick up. So let's do it like this. If it will not work, then we try with the queue. Okay. So if you schedule here P3, then P3 will consume next 2 cycles. So let's say till 6 P3 was executing. Okay. Now in another cycle again P1 will be scheduled. So P1 was requesting total 5 cycles. Again it will consume 2 cycles. So till 8 it will be executing. Now then P2, again P2 will be scheduled. P2 will again consume 2 cycles. So till 10 P2 will be executing. Now then P3 will be scheduled. P3 will consume 2 cycles. So till 12 it will be executing. Now this P3 has been done with its execution. Now when we schedule P1, P1 will consume only 1 cycle and it will be terminated by 13. Now remaining 3 cycle of P2 it will consume and it will execute till 16. Okay, so this will be the possible Gantt chart for round robin. Now let's check it. What will be the possible answer? So it is saying the order of execution for shortest job first P1, P2, P3, P1, P2, P3, P1, P2, P3. So that means D and B will be wrong because it is P1, P2, P3 only, right? Now if we talk about in round robin, okay, the completion order of the process, right? So if you check the completion order in round robin, first which process has been finished, you check it here. So last P2 is finishing, last P2 is finishing. That means we need to maintain the queue. Okay, so better you draw it with the help of queue, then only you will. Okay, P2 is finishing here, here you are finishing P3, so I guess the answer should be C, right? P2 is last, here P2 is last, but here P3 is last. Okay, so you can check it. I guess C will be the right answer, right? Okay, so if you have already understood this, we can move on to the next question. The next question is this: consider 4 processes PQRS scheduled on a CPU as per round robin algorithm with a time quantum of 4 unit. So please note down time quantum is of 4 unit. That means once a process get the CPU, it can consume the CPU for maximum 4 unit of time. Then it will be interrupted. The processes arrives in order PQRS at time T0. So that means every process is having equal arrival time. That is 0. There is exactly one context switch. Okay. So you remember one context switch from one context switch from S to Q. Then exactly one context switch from R to Q. One only. And exactly two context switches from Q to R. Okay, so that we need to ensure. But there is no context switch from S to P. So S to P, there is no context, so zero context switch, no context switch. And what is the meaning of context switch? When one process is executing, another is coming, or they are considering here, another process is also considered as a context switch. So when I'm saying one process is terminated, so let's say P1 was executing and it is terminating and P2 start here. This is also we are saying we consider this is as context switch. Okay, so when in case P1 is terminating and after P1 P2 is starting, that means this moment is also considered as context switch. So please do remember, right? Now let's draw the Gantt chart and easily you can get the answer. This is one of the easy question. So let's draw the Gantt chart for very first situation. So I'm drawing the Gantt chart for every situation. So the Gantt chart for option A I'm drawing here. Now A require like 14 plus 6, 20, 22 length Gantt chart. So you can draw the 22 length Gantt chart somewhere like this. Now this is for option A. So this is 0 moment. Now if it is round robin all arrived, so first you will schedule P and time pointer 4. So till 4 the P1 was executing and P1 is over now. So P1 finished. Now Q has been scheduled till 8. Q will execute. Then R will be scheduled for next 4 cycles. So that means 12. Then for next 2 cycles S will be scheduled, that is 14. Now S is also done. So again Q will be scheduled for next 4 cycles. 4 means you are having 18. And then remaining 2 cycle of R will be consumed. So R will be executed till let's say 20. And then remaining cycle, 2 cycle of Q will be consumed and let's say the Gantt chart is finished as 22. So this is A option. Now let's draw the Gantt chart for B option. So in case of B option, what is given here, you can check it. Right now we are solving every question in detail so that you will get the idea how to solve the questions of GATE exam. Initially P1 will be scheduled and this time P1 requesting only 2 cycles, so it will finish its lifetime by 2 only. So it is done. Then Q will be scheduled. So it will consume next 4 cycles, so it will execute till 6. Then R will be scheduled, R requesting 5 here, so 4 will be given here, so that means till 10 it will execute. And then S will be scheduled, S requesting only 1 cycle, so till 11. S is over now. Q is also P is also finished, so Q will be scheduled and Q will be scheduled for 4 next cycle, so that is till 15. Now Q is requesting remaining 1 cycle, so that will be completed in the next cycle. Now once you schedule R here, R will consume only 1 cycle, so till 16. Right, remaining 1 cycle, your this Q will consume here, right? So it will finish by 17. This Gantt chart is going to finish by 17. Okay. Now C, if you draw the Gantt chart for C option, then the C option Gantt chart Total requires 16 plus 5, 21, 25, right? 25 cycles. So let's say I assume this is 25 till this. Now you draw it. So initially P1 will be scheduled. P1 consumes 4 cycles. P1 finishes it here. Done. Q consumes 4 cycles till 8. Then R consumes next 4 cycles till 12. Then S consumes 4 cycles till let's say 16. Now S is over. Then again Q will be scheduled for next 4 cycles. So let's say 20. Then R will be scheduled. R will continue till 21. Only one cycle is left here. Then remaining 4 cycle will be consumed by Q again. So it will be finishing by 25. Now let's draw the context diagram or Gantt chart for D option. So in D option, the Gantt chart can be drawn like this. This is the zero moment, and total 10 plus 10, 20 length Gantt chart will be there. So first P will consume 3 cycles somewhere here, and then P will be completed or finished its lifetime. Then Q will consume next 4 cycles, so that means till 7. Then R will consume next 4 cycles, so let's say till 11. Then S will consume next 3 cycles, so let's say till 14. S is also over. Then Q will again consume next 3 cycles, so let's say till 17. And then R will consume remaining 3 cycles, so let's say till 20. The diagram is over. Now quickly check 1 Q2 S2Q. S2Q, there is only one context switch, so that is fine. R2Q is 1, R2Q is 1, there is no R2Q switch in this. Q2R, there are 2, so Q2R, 1 is here, Q2R, 1 is here, so there are 2, it is fine. And S2P, there is no context switch. S2P, there is no context switching is happening, so A option is okay. A option is okay according to the given scenario. Then check B option. S2Q context switch, there is 1. R2Q, there is 1. Q2R, there is 1 here. Q2R, there is 1 here. So 2, that is also fine. S2P, there is no context switch, so this is also okay. Then the third one, S2Q, there has to be 1. So there is only one S2Q. R2Q, there is only one R2Q context switch. Then S2P, no, Q2R2, so Q2R1 is here and Q2R1 is here. And S2P, there is no context switch from S2P, so this is also fine. I hope the answer will be D. So let's check it. S2Q, there is one context switch, it is fine. R2Q, there is no context switch. R2Q, there is no. So that means D is the wrong one and D is the right answer. Okay. So I guess you are clear on this. Let's solve one question from GATE 2020 and then we will close this lecture. So consider the following statement about the processes state transition diagram. Okay. And I guess you are aware about the state transition diagram, right? So let me recall. Okay, so state transition diagram generally looks like this. Now let's consider the statement. A running process can move to ready state. Running process can move to ready state like this. The transition is defined. So running to ready, a transition is possible. So this statement is okay. I would say true. Then a ready process can move to ready state. If a process is in ready state, if it is not going anywhere, then also it is in ready state. So logically you can say it is also possible. A blocked process can move to running. Blocked means waiting. Waiting to running, there is no transition. That means it is false. And a blocked process can move to ready state. If a block means waiting state to ready, there is a transition possible, this transition. So that means it is also true. So the answer will be first, second, and 4 will be true. First, second, and 4. First, second, and 4. First, second, and 4. That means C is the right one. Okay, guys. So I'm closing this session. Thank you. In next session we will be solving multiple problems on priority, non-preemptive priority queue scheduling and preemptive priority scheduling. Thank you. See you in the next session.